Good morning, GPs. Hopefully you had a fabulous May G4 weekend. And hopefully you all are there safe and sound. All right, so as I told you already last week, I'm not here today, but you still can't get rid of me, so we have a recording. So we're starting our last spiral, and it's spiral 3. So for anyone that has chosen the 3M course for next year, almost everything we're doing in this spiral 3 you're going to need for that course. So today what we're going to look at start is quadratics, but we're going to be graphing in vertex form. Now you know from before that we've looked at quadratics before. We found regression equations for them. And so in other words, those were the times also where I demonstrated where I took blackboard brushes and I threw them around the room to demonstrate that often we talk about quadratics when we're talking about projectile motion. Okay, so that's what today's lesson is kind of all about. So with the quadratics and with graphing, we're graphing when the equation is in a thing called the vertex form. Now that really doesn't mean too much to you at the moment, but I don't know if you remember, we had seen the word vertex before when we looked at quadratics. And so the first thing we're going to do is we're going to review some of the key components of a quadratic, especially its graph. Now, often because we looked at projectile motion, we often looked at something that was a U shape opening down. But what I'm going to do is I am actually going to start it somewhere else, not opening down, but actually opening up this time, just, just so that I have some fun with it. So here I have one arm of it, and you know that there's another arm because I don't know if you remember this, but remember I took some blue paint and I put it on a piece of paper and then folded it. And I only put one arm on my paper, and when I folded it over, it created a shape something similar to what we have here. And we talked about where that fold was on that paper was this imaginary line. And that imaginary line was called the axis of symmetry. So we're just going to write down axis of symmetry. So what that means is it's like a mirror point. And you study that, especially when we talk about art. Now, the thing about the axis of symmetry, if you notice, it went through this point, and in this case, the point was the lowest point of the graph. And that lowest point is called the vertex. Now, the vertex is special in the sense that it's the place where the graph changes direction. So when we have a quadratic that opens up, I'm going to just put this for a second. When I go across, okay, so now we're seeing the red graph starting, and you can see that it goes down and it goes down, it goes down until I get to the vertex point. And now when I remove this, you can see that it goes up. So the vertex is special in the sense that it's the location where the quadratic changes directions. And the same thing would happen is if I drew a quadratic over here, and that's supposed to be an arrow, it doesn't look like one. So here would be the vertex, and the same thing applies to it. When I put the shade over it, as I come across the purple graph, it's going up, up, up. I get to that vertex point, and now the graph changed directions. It is going down. So the vertex is important in the sense of that. So we say the vertex is almost like the starting point when we're graphing things. So I am going to put the word starting point because actually we're going to use that as our starting point when we go to graph. So what else do we know about these graphs? Well, there's a few other things that we talked about. Graphing vertex form doesn't necessarily make those places that important to us right now, but we know that when it crosses the x-axis, that's important. Okay, so those are the x-intercepts in the sense that they intercept the x-axis at those locations. Now, it's possible that you have a parabola, in other words, a quadratic, that doesn't touch the x-axis, and that will be dependent on where the vertex is located and whether the parabola opens up or down. Okay, now notice I'm often referring to this as quadratics, but I'm also using the word parabola. Now, we talked about parabolas before, and the graph of a quadratic is actually, its special name is called a parabola, not a parabola. It might spell like a parabola, but it's called a parabola. Okay, so we have our vertex, axis of symmetry, we have our x-intercepts, and in most cases too, we're going to have a y-intercept. And again, that again depends on what we can see on the graph. Sometimes we can't see the y-intercept. Most cases we can, however, it's a little bit different than the x-intercepts. So this is called the y-intercept. So pretty much everything I've talked about here is things that we have seen before in previous spirals. So it's just trying to bring it from the back part of your brain to the front so that we're going to be able to use it. So as I said, our title is Graphing in Vertex Form. So the reason it's called vertex form is the way the equation is written down, we can read the vertex from it. And that's what you're going to be learning. So the first thing that we need to do when we're talking about this is we're going to talk about the parent. Now, just like you have parents, most of you, I think, um, your parent kind of defines all the children afterward. So, for instance, we're going to study the parent so that when we change the parent, we'll see some features that are the same between all parabolas, but where there's been variation added to the parent. So it creates a new parabola or a new quadratic function. So the parent of all quadratics is this. It is y equals x squared. Okay, so we've seen that before. We know it's not linear because the x is squared. Okay, in order for it to be linear, both of the x and y would have to be the power of 1. So this is the parent. The vertex of this parent is 0, 0. And we always want to be able to find the vertex because, as I told you before, in most cases, that is our starting point. So if I go to my graph, I'm going to find the origin, so in other words 0, 0, and that is my first point on this parent, on the equation y equals x squared. From that, it depends what teacher you have, but I think it's the easiest to create what I call a step pattern. So when we're talking about a step pattern, we're talking about over and up from things. So it's a step pattern, and this is the step pattern for many, many quadratics. And so what there is an over, and that over is going to be over from the vertex and then up. So now if I just making a little table here. So it's something like a table of values where you have an x and y, and actually for this parent it is the x and y. However, we're going to then take this step pattern and apply it to other parabolas, other quadratic functions that are related to the parent but are not the parent. So what we're going to do is we know that we have this axis of symmetry, which is going to help us. So if we can just figure out one side of the arm, then we can use the axis of symmetry to translate over to the other side. So in most cases, we're going to go over 1. And what that means is because this is squared, it's going to be 1 squared. So 1 squared is pretty easy. It's 1 times 1, which is 1. Okay, then we're going to go back to the vertex and we're going to go over 2, and then we're going to do 2 squared, which is 4. And finally, because I think that we only need one more point, we're going to go back to the vertex and go over 3. 3 squared is 9. So this is the step pattern, and when I'm back in class tomorrow, you're going to see me jumping around doing this step pattern all over the tiles on the floor. Okay, because it's one easier way to remember how to graph. So let's graph these points. So I go to the vertex. Okay, I go over 1 along the x, up 1. So there's my point. And I think I'll maybe change to red so it's easier for you to see. I go back to the vertex. I go over 2 and then up 4. I go back to the vertex. I go over 3, up 9. Now I could keep on going, but obviously I'm writing a grid because I could go back to the vertex over 4 up 16, okay? But usually we don't try to draw graphs that much. Okay, so these are the points, and I can actually join them and I can get that one arm, or I'm going to use the axis symmetry to get the points on the other side. Okay, so this is a distance of 1, so this one goes over here, and then we're just, as I said, using that principle of symmetry to get all those points in there. So now it's just a matter of joining them together, and I do apologize before I do it. It's a little bit harder for me to do it when I'm not, well, even when I am using the smartboard, okay, to get a nice smooth one. Yeah, it looks a little wonky, but you get the idea. And now I'm going to put arrows. Okay, so this is the parent, and in a sense, this is what I really need to remember to graph almost everything. Now what I'm going to do is I'm going to stop this video, and then we're going to look at, okay, what happens if my equation is not the parent? We want to see how could I graph it then.